Y'all for joining. This is excited to kick off the first virtual brew of 2025 this year. And we're going to go ahead and get started by talking today's topic, which is really about managing and interrupting bonds safely and efficiently. Oops, here we go. So what is that? What are we going to talk about today? So kind of what we're going to go through, we're going to be talking about what actually is a bond. And if you're not familiar with a bond, these are very common as items used in various CP systems to help with making sure that the CP system is working effectively. So we'll be going through what is an interference bond, and then some items about what you probably heard the term, what is a critical bond. So we're going through what might make a bond critical, especially with looking at what PHMSA cites as what a bond may be, they'll be considered critical, as well as performing interrupted surveys with bonds. And finally, kind of how we can look at improving efficiency performing these surveys and managing your bonds with remote monitoring units. So to kick us off, I did want to use sorry, y'all. Everything, as I was just saying about using a new platform, all the buttons are in different places, so bear with me. To kick us off, I wanted to start off with running a quick poll. So I'm going to share that in the chat now, but I just kind of wanted to gauge the audience. How many of y'all in the audience right now are managing bonds in your CP system? Okay, so, and in case y'all aren't looking at the chat, looking like over 60% of our audience are managing bonds. Okay, so that's fantastic. So that helps me understand. Yeah, y'all are probably pretty familiar with bonds. And if not, I'm still going to go into more detail on bonds for the whole audience. But that is awesome to know. Thank y'all for engaging with me and bearing with me with the new platform. So apologies. So we're going to jump into this and just kind of go over what is a bond. It may seem simple because some of these in their basic terms is pretty simple. When you look at what an interference bond is, or often also called a resistance bond, depending on application, is quite literally a connection, usually in the form of a wire or a resistor, often a shunt, between one pipeline and another pipeline, used to help prevent corrosion between the two pipelines. This is also really common in an area where you might have crossings between two or more pipelines, or if you have very crowded corridors where you're going to have a lot of pipelines in one right of way, which I know now there's no more land everywhere and more pipelines are built every day. So we know that this is becoming more and more common whenever we kind of look at there are more and more pipelines being laid in the same corridors with other pipelines. Some of these pipes have been around for 50 years or older. So there's a lot of situations where this would come up. So just kind of as laying out what that looks like, often if you have two crossing pipes, so as an example, here's company A's pipeline. They have a CP system. They have their rectifier and anode bed set up on their pipeline. And there's another pipeline company, there's another operator in that same area with a crossing. So this is very, very common. I imagine if I sent another poll in the chat here, almost everybody would say, yes, we have this happening on our pipelines. So what that actually looks like in practice is when you have your CP system turned on, you're providing CP protection to your pipeline. In this case, company A, we're assuming that's my pipeline in this scenario. So you'll be looking at this pipeline and your CP system is on. So your current's flowing through your rectifier to your anode bed, applying CP, and in that case, protecting your pipeline. But since there's a crossing, and in this scenario, company B is not a protected pipeline, just for the sake of our scenario, sometimes there may be, depending on the resistance of the soil buried around your pipeline and the different voltage potentials between these two pipes, the current that's on your CP system might think, oh, that other pipeline looks really appetizing. There's no resistance. I'm going to go that way. So that current may jump from your anode bed over to this other pipeline and start flowing on the crossing pipeline. When that happens, then at some point that current is going to want to jump off of the company B's pipeline. This could be due to the crossing, or there's less resistance in another area of the pipeline, and that current's going to want to flow wherever there's least resistance, right? So in that case, in this scenario, it's going to jump back to my pipeline. But when that jumps off of that spot, that's a potential area for corrosion to start. And that would be corroding on company B's pipeline. But if that current decided to flip directions, it would start corroding my pipeline. So either way, that's a problem. And we don't want that to be happening. And then that's kind of finishing out our circuit, right, of going back to my pipeline. So to mitigate this, I know a lot of people will start adding an interference bond. And in this case, you'll be hooking up company A's pipeline to company B's pipeline with a resistor in some form. In this case, I have a shunt. So once you hook that up, now the current decides I'm going to now have the path of the least resistance is through this wired resistor. So I'm now going to flow through this bond and back onto company A's pipeline. So now this in theory will then prevent corrosion from occurring on company A and company B's pipeline and keep the current flowing in the same direction throughout consistently. And so that's kind of the main reason why a lot of these bonds exist and are out there in the world. And when you look at what PHMSA discusses as a bond too, this type of bond has to be looked at least once a year, not exceeding every 15 months. And I have the actual reference there. It's from PHMSA 192. That's to have the actual citation here in this, just to make sure we all know where I got this data from. But pretty much it's just like looking like some other CP assets. You have to check these bonds once every 15 months. And that's why they are out there to help prevent corrosion. But you probably have heard the term critical bond as well. So what would make a bond critical? So per what PHMSA says as well, I'm going to go ahead and, basically, what makes a bond critical in this case is if you have a resistance bond that if you removed that bond or that bond was disconnected, like we talked about in the last scenario, there would be a loss of cathodic protection on any of the affected pipelines that would allow corrosion to occur. And then, of course, that would jeopardize safe operation of either bonded pipeline in this case. So let's say I took away that interference bond. Now there's another hot spot and potential spot for corrosion. So per the guidelines of what, of course, this also can vary based on the operator because that can be considered kind of vague if it can cause corrosion. But if we look directly at what PHMSA specifically highlights, just looking at what this says, basically what I said above, any interference bond that would, if it failed, would jeopardize structure protection. It has to be checked and is deemed as a somewhat critical or more important bond. So, and there's a bit of a difference there. Now, since it's considered critical, it must be checked at least 6 times a calendar year. But within intervals, basically every 2.5 months, you would have to go and inspect this critical interference bond to ensure that there's no metal loss and there's no corrosion. It's treated just like a similar requirement to checking out your rectifier assets. And also, if y'all have questions, please feel free to throw them in the chat as we're going. I try to keep an eye on it while we're talking, but this way we'll be able to actually look at, I can catch them while we're talking. But again, just to really briefly recap, a critical bond is a bond when, if it was disconnected, you would probably lose the adequate cathodic protection. And so it would jeopardize the safe operation of your pipeline. And these bonds are also very important because it will help determine the direction of the current flow. So as an example, if I go back and see this bond is flowing, like I said, from company A to company B. And with that bond intact, it tells me that it's flowing in the direction I want it to flow. I want it to go from A to B and then back to A. And so that way I know the direction that the current is flowing. If that bond is removed, or I don't have any, and I'm not checking that bond, I may not know when that current is deciding to flip directions and jump from A to B or B to A. And so then that could potentially cause corrosion on both pipelines, if not bonded. So next, we're going to briefly go into kind of what do interrupted surveys look like with your bonds, and some critical measurements that you probably want to be taking to make sure you're capturing the health of what your bond, the actual health of your bond. So just a few important bond measurements that you're going to want to capture. So first one that we always recommend is getting your pipe to soil measurements for the structures at that bond while they are bonded. And the reason being, so basically that would be measuring the potentials on your structure while they are bonded together. This is really key to understanding if your structure is adequately protected while connected to your foreign structure. So kind of talking about what we talked about on the last slide, wanting to understand how is my pipeline being protected adequately while connected to this foreign structure. Then the next measurement that we recommend people take too is taking that same pipe to soil, but with that bond disconnected. So that would be taking the potential measurements on your structure while your bond has been disconnected. Reason being, that really helps to understand, kind of in the name of an interference bond, understanding the interference that your structure might be experiencing from the foreign crossing. That would be very important in understanding what the actual interference that you'd be encountering is on that structure. Then kind of lastly, another measurement that we recommend taking too, really to kind of tie it all in and understand what the health of your system is the bond current. So in this case, if you have a shunt or other resistor that's bonding your two structures together, you'll want to take the measurement across that bond, across that resistor. That way you'll be able to actually see, really key to understanding which way the current's flowing. So you'll know if it's supposed to be flowing, if it's a negative potential, you know which way it's supposed to go. Positive, you know it's supposed to be going the other direction, as well as understanding, seeing that the bond is actually working correctly. Because if those bonded structures, depending on, especially in the scenario that I showed previously, you might be seeing equilibrium between the two structures, pipe to soils, based on the current that's on that bond. And here's just an example of I just threw a whole bunch of things out there for those that aren't as familiar with what a bond might look like. Here's an example of a test post. So this is a 3-inch riser post that has a single bond site with a shunt. So that COT shunt in the middle there, that red shunt, is bonding these two structures together. And so when I was just talking about taking those potential measurements, you'll want to take that bond shunt measurement on that shunt itself with your digital voltmeter and your MESA tablet as an example. And then you'll want to take the pipe to soil measurements of whatever the structure 1 is, which is maybe your structure or your crossing structure. You'll want to take the measurement of the second structure and be able to have all that data together to know truly what is the health of my bond and is it doing what it's supposed to do. And by that being keeping my pipeline protected. So then we'll just kind of briefly talk about when you're performing some of these close interval surveys, most often, because the close interval survey is an interrupted survey, you'll want to have to be interrupting the CP system that's on your pipeline while performing that survey. So oftentimes we usually see this by to remove any interference and get the true health of your pipeline while performing the survey, you'll want to disconnect your bond. And then, so after you already captured all those measurements that I was talking about on the previous slide, go ahead and disconnect the bond. If you're doing this a manual disconnection, you'll want to disconnect the shunt or the bond between the two structures and then begin performing your close interval survey. So now this is kind of what you're looking like here. There's no more interference bond. You'll just purely have company A's, in this case, your company's or your pipeline. You'll want to be performing the survey on your pipeline with your interruption cycle set by your portable interrupter, like your Micromax, or if you're using a bullhorn remote monitor, setting up your interruption cycle that way. There we go. Yeah, so once you disconnect the bond, you're going to go ahead and perform your close interval survey as normal. And again, if anyone has any questions, well, feel free to throw them in the chat while we're going through this, and then we'll also have time at the end to answer more questions. So we've talked about what bonds are and what their purpose is, as well as how to manually disconnect them and perform surveys. But and with the required compliance measurements that you should be taking to ensure that your pipeline is healthy. Now, briefly, everything I talked about, you probably heard was a lot of manual disconnect, manual this, take this apart, spend time taking a manual measurement. So that's not as efficient when you're out in the field. I've been out there myself and done this, and it sometimes can take upwards of 15 minutes to just go ahead and remove, especially if you have multiple bonds in one box. It could take a long time to manually disconnect all those bonds and get your interruption cycle set up for your surveys. So by using bullhorn remote monitors, you'll be able to actually capture all those measurements that I was just talking about remotely. So I know per PHMSA requirement, these have to be visited every so often, as every few months, and have to be capturing measurements on these, especially if they're a critical bond. So by using a remote monitor for these, you can remove all those, you can reduce the amount of times you have to go out into the field and physically take all of these measurements to be able to build your long-term look at the health of your bond and your pipeline, all from your desk. So I can do it right here from where I'm giving my presentation to y'all today. So especially if you're using our 520 interruptible bond monitor, you'll be able to capture the pipe to soil measurements for your pipe, the bonded structure, and your shunt current measurements, all with just one button click. Be able to capture all of those measurements at once. And also a really big additional value from using a remote monitor and improving that efficiency, like I was talking about, is you don't have to manually interrupt your bonds anymore. So this has been, I have heard this story before, and I imagine everybody in the audience has a story similar to this. I remember talking to some customers and talking to some technicians, and they were performing their interrupted survey. They had a really crowded corridor, so they had a bond box with multiple bonds in it. And to perform their survey accurately and correctly, they disconnected all their bonds, as I was talking about in the previous few slides. They performed their whole survey. They were out there for a week, did all their survey work, and left. And they forgot to reconnect their bonds. So that didn't cause any problems for them at the time because they caught it early, but this is a situation that happens all the time. And I know if you're anyone like me, I forget very small things all the time too. So forgetting to reconnect your bonds happens often. And if you're using a remote monitor, if you're familiar with the bullhorn line or you're not familiar with the bullhorn line, basically, and have used portable interrupters in the past, it's just like setting up your interruption cycle 3 on, if you're using a 3 on and 1 off cycle as an example. All you have to do is you use the remote monitor and be able to interrupt that bond remotely. So all I do is go to our webpage and click interrupt. And then while you're interrupting your whole pipeline as normal for performing interrupted surveys, you're interrupting the bond at the same time. So that's saving a whole lot of time at the actual bond site while performing your survey, allowing your crew to get done a bit faster, as well as be able to capture the same measurements that I was talking about while the CP system's on and off through the instant and on and off measurements while interrupting. So using remote monitors on your bonds will save a ton of time and save your crews a whole lot of headache of just even trying to remember, oh, which bond was which? Is this my pipe? Is this guy's pipe? I can't remember. So this will just save your crew a ton of time and make your survey work a whole lot more efficient, while also giving you an extended, healthy look at your pipeline and at your bonds, especially critical bonds. So with that, that's actually the end of my content today. So I did want to go ahead and open up the floor to questions. And thank you all for having me today. And again, just as a brief recap, we talked about a lot in a very short amount of time. So feel free to send questions in the chat here, or we'll be able to respond to you post-meeting if you want to follow up with us after the event. But we talked about what is an interference bond and what are critical bonds. And what does PHMSA declare those as, and and the reporting cadence of having to look at those bonds, as well as performing interrupted surveys with bonds, and then now kind of improving the efficiency with remote monitors with your bonds.